Good day. I am Joanna, and I will be presenting on behalf of the Group 5. In this video, we will be enlightened by how mathematics created natural phenomena in terms of their observable patterns. But before that, let us first define these terms: patterns and natural phenomena. A pattern is a sequence that is based on a rule. Take a tree for example, it is formed from recurring lines. It is as if the trunk makes smaller copies of themselves, which results in branches. And they too also make smaller copies of themselves that become twigs. Natural phenomena are any event that is natural, that undergo either chemical, biological, physical, or geological changes. For instance, a volcanic eruption is a natural event that undergoes geological changes. What do these terms have to do with mathematics? Well, mathematics is actually a study that examines and uses patterns in order to make new notions that may explain the world around us. Or specifically for this presentation, natural phenomena. Now, let's have a look at the team members' observations. First, we have Abigail's observation. She considered a lightning strike as her object, in which she noticed a pattern of a fractal. A fractal portrays repeating patterns in different sizes. Or it can be regarded as a self-similar figure. In this case, a lightning strike shows similar lines in varying sizes. Next, Shekinah, who spotted a pattern in an aurora, or the famous northern lights, said that this natural phenomenon follows a meander pattern. A meander is a stream of curves, loops, or windings. This pattern is also typically found in rivers. For this example, we can see that the northern lights stick to a flowy pattern called meander. Then we have Lytle, who noticed that ocean waves or any oceanographic phenomena possess the pattern of a wave. Waves are any disturbances that bring energy as they move. Considering any type of oceanographic phenomenon, we could all agree that waves indeed are observable. Following this observation is by Junlin, who examined the pattern followed by an earthquake. She perceived that during earthquakes, there are usually cracks on surfaces, may it be on walls, floors, or the road. Cracks are formed to relieve pressure, which results in linear openings. In the course of an earthquake, materials shake and move, and to relieve the stress, they form cracks on the surface. Next, Junil studied a sundog's figure, whereby he observed a symmetrical pattern. Symmetry is a pattern in nature, in which an object is made up of two equal parts. When you draw a line in between the object, you could see that they are each other's reflection. In other words, it has a balanced proportion. A sundog, when divided into two, does have equal parts. Lastly, CJ observed an extremely rare natural phenomenon. That is a tessellated pavement. A tessellated pavement is a flat, rock surface that is subdivided into polygonal blocks. As suggested by the name of this natural event, CJ noticed a tessellation. A tessellation is formed by repeated tiles of geometric shapes. This image of the most well-known tessellated pavement, found at Loufra, Eaglehawk Neck on the Tasman Peninsula of Tasmania, is pretty self-explanatory. Now, those are just some of the various natural phenomena whereby patterns can be observed. So here are other examples to further deepen our understanding. A snowflake is an example of a fractal, since it is self-similar, in the sense that it repeats the same shapes over and over again. Another example is during a drought. The mud is dried, consequently forming cracks on the surface. Also, crepuscular rays manifest a stripe-like pattern. Furthermore, storms, tornadoes, tsunamis, and other events revolve around the so-called Fibonacci sequence and the golden ratio. Now, what are these terms? To put it simply, the Fibonacci sequence is basically adding the last number of the equation with the sum of the previous equation. So let's say, 0 plus 1 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, and so on and so forth. Now these series of numbers, the sum of the equations, follow the golden ratio of 1.16, as you can see here in the illustration. So in a rectangle, if we follow the golden ratio, we will yield the Fibonacci spiral like so. To illustrate, here are images proving that the Fibonacci sequence is embedded in nature. If you want to learn more, please view all of our references that will be shown at the end of this video. In conclusion, mathematics is everywhere. As Galileo Galilei said, mathematics is the language in which God has written the universe. That is all, and thank you for watching.